All right, good evening. So we are working on we're working on functions relations today. I think we have to do, I think that does domain and interval notation stuff as well. And that's where we are, I believe. Oops, I don't want to put one. Oh. All right, well, let's do this. I don't know what happened to my little sheet here. All right. All right. File save. February 4th. There we go. College Algebra. Exports. That's what I wanted. There we go. Get rid of that. And we have this. All right. So, all right. So we do some function notation and hopefully some intervals. Okay. Okay. Hey, we did one of these yesterday where we had to replace it with an A+2 or something, right? Okay. Okay. Let's have a look at that one. That's good. Start up. All right. So again, evaluate. We'll do a little bit more with this one. So we have evaluates. We'll say h of x is 5 over x for the given values. Okay. And then they pretty much ask us, like, what is h of 6? Okay. And what they want us to do here, right? So just going to replace that x with the 6. So it's just going to be 5 over 6. Okay. That's all we're supposed to do with that. If it was h of 10, right, we would just type in that. Sometimes they get fancy, right? And they want to do what is like h of like a minus 2. And that's all we can do. Actually, for this one, the problem I would have asked would have been something like, I would ask something like b plus 5. Because what I'm hoping to do, I'm hoping to trick you into thinking that you can simplify this and that you'll try to do this. And you can't do that. Okay, you can't pull apart the denominator like that. It's got to be times. It'll work. But if it's actually, here's another one I would do with this. Okay, is we would say what's h of 5a, right? And that would be 5 over. Now you can do that. There's a times in between here, so that's just going to be 1 over a. Okay. Or I would want to do something like this. What's h of 1 over a? That's 5 over 1 over a, right? So what's 5 divided by that? That's what that means. So we just get a 5a instead. All right, so I don't think they ask you that. I don't think they do that to you at all. They do this and they say 5, 6, and they're done. But that would have been boring. So that's why I would have asked the other ones. I do. I miss not being in the face-to-face stuff anymore. All right, x and y intercepts. That's always a good one to do. 4x plus 24 equals k of x. Okay, so x and y intercepts. So y-intercept, that is when x is equal to 0. Okay, if you have trouble remembering that, right, you've been tormented with this thing for years. Okay, maybe years and years ago, but you've still been tormented with this for a long time. and they go out of their way to tell you that it's slope-intercept form, okay? So you know the intercept, which one? It's like, this is the y-intercept, okay? So always go back to that, you know, equation of a line and realize that that is my y-intercept. Like, why does it have y-intercept? Because we set x equal to 0, okay? So when we're looking for the y-intercept here, right, we have k of 0, which is 4 times 0 plus 24, which is 24, okay? Now, that's y-intercept. The x-intercept, we're taking turns. Okay? Now y gets to be 0, right? X got to be 0 in the first part. Now y gets to be 0. So we have 4x plus 24, set that equal to 0, and we're solving for x. Okay, so we're going to go ahead and subtract the 24 from both sides. We have 4x is equal to negative 24. Divide both sides by 4, and we get x is equal to negative 6. Okay, so my 2 points here. Here's my y-intercept, right? That is 0, 24. My x-intercept is going to be negative 6, 0. Okay, first one, x was 0. Second one, y is 0. All right, and we'll just type that in. Oh, we just want x and y intercepts. Okay, we don't need to do that. What is this? This was question 13. All right. Oh, this is a nice one. This is a good problem. Domain and range. Okay, so here what we're going to do is we're going to figure out what are all the legal values of x. Okay, what are all the legal values of x? So it looks like the smallest number we have in the x direction here, right? It's negative 1. So, or yeah, negative 1. But did we actually get to negative 1? Or did we have to get almost there but not quite? And that open circle means it's almost there but not quite. So this gets a parentheses. Okay. And then what's the biggest x? Well, from this arrow, it looks like it's just going to go on and on and on and on. So we're going to do that. Okay. My range, right? That's all the legal values of y. Right? All y values. Well, what's the lowest value I have for y? Looks like 1. Does it touch 1? Oh, a lot of times. So we're going to go with 1. And again, we got an arrow pointing up, going up, 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 and up. So that would be our range. Okay. So that's, let's see if 19 gives us a very similar problem. How about 17? Does 17 give us a problem like that? 20? Okay, we can do that one. Domain and range. Okay, this is actually an easier problem, I think. So, what are all the legal values of x? Okay, it's like a parabola facing down. Even if it's off the lumber line, right? Put a problem here. If we go down far enough, we'll find it. All right. So the domain here is all real numbers. Okay, and generally, when you have a problem, polynomials, that is generally going to be the range. Okay, it's almost like a trick question. It's like, what's the range? Like, what's the domain rather? Like all the numbers. Okay, and then the range, that's a little bit trickier. All right, it looks like 3 is the biggest number we have here. So they always go from smallest to largest. So we're going to go with 3. All right, so we're including the 3 because of the bracket. Right? We're including the 3, and we're saying that's the highest y value that we have here. I think that's a pretty good choice. Now, as far negative as it goes, we can't really say. Negatives always get the not included part. Okay, 3 could have been or could not have been. If there was a little hole here, then we would have written another parentheses. But since it hit 3, we're good. All right. Oh, there we go. Domain again, and I'm not gonna. One problem. Okay, slightly more interesting. Okay, so the domain here. Okay, well, 5th roots, 3rd roots, 11 roots, they all have the same shape. They all kind of be a cubic shape, but they're going to be flatter. Let's see. Can I do this? Just to have a look at it. All right, if I do y1 is equal to x, x to the 1/3. This is the cube root of x, right? So when you write it as a fraction this way, it's the cube root. Okay. So let's compare it. Okay, this is x to the, now let's do a 1/5 in here. Right, so the green one is the 1/5, the red one is the 1/3. So you see how the 1/5 kind of flattens out a little bit faster? Okay. And what do you think is going to happen to like 1/7? Right, it's going to flatten out even more. It's going to say, okay, 1/7. Okay, that's a 7th root. That one's harder to see if you go out far enough. And kind of go over here. So as we get close, as we get bigger numbers here, there's less space between them. Okay. They will condense up around 1. They'll change positions. You can see that, right? 1 is the biggest number, and it turns into the smallest number. So between 0 and 1 or 0 and -1, it's a little bit different. But you could look at this graph, right? The red one. All right. And it is. No matter how far I scroll out, there's more there. So this one, cube roots, 5th roots, 7th roots, all of the odd numbered powers, their domain is all reals. Okay. So this domain, -infinity to +infinity. Okay. I really wish again that we had face-to-face, because I'm happy if you write something like that. Like that symbol means all real numbers. But since it specifically asks about interval notation, we gotta do something like this. Okay, all right, we'll do something like that. Looks great. All right. So these two, I don't have to solve for 0. I don't have to do anything. I can just say, oh, that's a 5th root. Their domain is all the real numbers. Okay. So it is. It's kind of a trick question what they're doing to us. Now this one they put in a fraction. Okay. So it's okay for it to be negative, but it's not okay for it to be 0. So I'm looking at this problem, and the only number that's going to put a 0 on the bottom here is 6. So this number, this one, can't be 6. Okay, so 1/, I don't care what you put here. You put a 5, 7, 11, I don't care. It can't work. Or it won't matter for that one. But this one, x can't be 6. That's where it's going to blow up. All right. How do you write x can't be 6 in interval notation? Right. Again, face to face. We can say it's all the real numbers except 6. But they ain't going to let you do that. So we're going to go -infinity up to 6, skipping over 6, and then 6 to +infinity. Okay, that's our interval that this thing is good on. So the only reason why we had to exclude 6 was because it was a fraction now. The 5th roots have nothing. We're not taking anything out of the domain for that. All right, let's see. Oh, that's right. I wanted to go back up here. Okay, look at this one. Oh, nice graph. Oh, okay. So this is practice reading functions. Okay, so we're going to consult this graph all the time. But what do they want to know? They want to know f of -1. Oh, they're going to make us do it piece by piece. Oh, jeez. All right. So when x is -1, what's my y value? That looks like 0. I wonder if they'll make me have 0 there. I'm annoyed that they don't have a keyboard way of doing that. F of 3, same idea. We're just going to go to 3, pop the function there. Say, oh, must be 2. All right, if there's more value, right, this is f of x equal to -1, and there could be more values, right? And f of x equals -1, we have a point here, we have a point here, we got a point there. There's 3 times where this is equal to -1. That's okay. The y's can cross a line, that's fine. If they do it more than one time, then we don't have a function because it fails to. No, that's not right. If the x's are if we have more than one x, we're going to have a problem. But I got confused from thinking about something we do in pre-calculus where it can't go twice. But yeah, it could hit there more than one time. That's okay. That's fine. So we're going to have one here with -2, 0, +2. Okay. So all values of x. They didn't ask for a point. They just asked for the x's. So that's going to be weird to check. All right. And then they're going to ask for -4, and etc. Okay, but I think you have the idea for a problem like this. Okay, and I try not to pick the problems that have like a gazillion points to them because I know it's like an exam, and I don't want to do points A through Z under every problem. That's not fair. If I'm going to say 10 questions and each of them have 26 parts, that ain't 10 questions. All right, so let's go back to I was trying to find a no. Yeah, something like this. No, that wasn't it either. It was when they had us asking about the A's. Okay, yeah. Evaluate the function for the given x, simplify your answer. This is f of p minus 2, and they give us this horrific thing. Okay, so we're going to say f of x is equal to x squared plus 3x. And then we're going to say f of p minus 2, that's going to be p minus 2 squared plus 3 p minus 2. Okay, hopefully that helps. I'm going to go ahead and factor one of these out. Right, so if I distributed this thing, I'm looking at it as one thing now. But if I distributed this back in, would we get the same thing? Right, we would get this back up here. Yeah, we get the same thing, so it's okay. So what we're going to have here is a p minus 2, and this is just parentheses. It's minus and plus. All right. -2 plus 3. So we just have to multiply that out, and that's how we're going to do it. All right. And that is going to be our value here. Okay, what is that? P squared minus 3p minus 2. So this is P, oops, I want Z, I just want P squared minus, what was it, 3P? Minus 2. Really? What did I miss? P minus 2 plus 3, P minus 2. No, that's okay. Through the P minus 3, 2's out of there. Still have one more to go. Let's try it the other way. But I know where I screwed up, right there. Oh no, that says it. We still have a plus, plus, plus. So this thing, we're going to multiply this out real fast. So that's P squared minus, right, minus 4P plus 4. That's this thing multiplied out quickly. If the people are trying to do this, it's P minus 4, right? P minus 2. So yeah, it's just by P minus 2. Okay, plus 3, P minus 6. What did I mess up? Minus 4 plus 1, minus 3, 6 minus 2. There we go. So we have P squared minus P minus 2. Yes or no? Okay, let's see. I was happy with that. Why didn't this work? Plus to minus. 2 plus 1. Oh, there's a sign. Minus 2 plus 1. There it is. Yep, you should have gotten a plus 2. Oh, at the end, did you get a plus 2? Did you get this 3 times negative 2 to get this negative 6? And in here, we should have gotten a plus 4. Plus 4 minus 6 should be our negative 2. All right, that's where, I think that's where the mistake would be, was this guy right here. I think it was a minus 6. And then add that. All right. But here, yeah, I got a minus and a plus. That should have been minus 1. That would have worked. If I kept my arithmetic sorted out, I would have been okay. All right. What are we doing? Yeah, that's the mistake everybody makes. And be careful about this, is that, and I do it too. It's like you get so excited, you're like, yay, I caught this. And you forget that there's a second one there. That's a very common thing that people will do. So be careful. That's why I try to do all my distributing on one line, is so that I don't get lost and mess it up. Okay. That was weird. Okay. All right, let's take a look at another section here. So I'm going to go ahead and knock this one out. You go back to Alex and say, you know, I'll bet linear equations is a good one to do. All right. All right. So, and by the way, I will never know, nor do I really care that much, which method you use. Okay, there's multiple methods of getting lines. I'm not going to police you and say you shall do it this way. All right, I don't really have a problem with picking the way that works for you, especially on an exam. I don't, if you're doing it a way and it works for you, I want you to keep doing it that way. But write the equation of a line. We have a couple of points here. We have negative 3.9, 5.7, negative 3.4, 4.3. Okay, so we have a couple of things that we're going to do here. We have to figure out the slope. Okay, and then we have to use point slope formula, which is this one. Alternatively, because like I said, I'm not going to check. All right, even if I did check, I do not have a problem with people using previous knowledge or other knowledge to get, as long as it's consistent, right? As long as you get that as long as you get that answer every time, then I don't really care. All right. If your way of doing division, right, is to do something like this and say, well, this is what we did in school. Like, well, you did get the right answer, but I know you did 2 problems. This would be the other one. Because this technique only works for these 2. Okay, it's the only pair that this works for. Everything else, I'm going to try this, do 12 over 24. Like that's not true. 12 over 24 is a half, not a quarter. So it doesn't work every time. So don't do that. But either one of these methods, they'll work both times. They'll work either way. They'll for everything. Okay. So we're just going to carry on here, and we'll have our 2a and our 2b, and we'll check. All right. So finding the slope, m, right, is equal to the change in y's over the change in x's. Okay, that's just a formula that you get to carry around with you for the rest of your life. All right. So we have our x's and our y's. And it doesn't really matter which one you call 0.1, which one you call 0.2. It really doesn't. So we're going to say this is going to be 4.3 minus 5.7. And then the x's are going to be negative 3.4. And then we have minus a negative, so plus 3.9. All right. So normally it would be minus, but we have minus and negative here, so now we're positive, 3.9. And if you want to put this in the calculator, that's fine. Okay, let me show you how to do that. Got to use parentheses, okay, because you got to group the top. 4.3 minus 5.7, and parentheses, divided by, we have 3.4 plus, oops, I really need a negative. Be careful with the negative you choose, because this is how you make a sign. This is an operator. So we need negative 3.4 plus 3.9. 0.9. All right. So there's my thing. I'm double checking to make sure I'm working over here. Looks like negative 2.8. Great. All right. That's my slope. Now what we're going to do is we're going to use both of these. We're going to use both methods. Okay, this will be 2a, where we're going to take y minus y0, or y1, m, x minus x0. And you get to pick which point would you rather use. Both of these points are terrible. Okay. Why don't we just take the first one out of sake of argument, right? So what we're going to do is we're going to say this is y minus 5.7 is equal to m. M we said was 2.8 negative. I'm going to go ahead and make that an actual proper 8 here. All right. X minus, we had a 5.7 here. We need a 3.9. Okay. So this is, what am I doing? Okay, so we have y minus 5.7. Here we are, we're going to distribute negative 2.8. Oh, so let's go through and do that. Let's track that. We'll do this one. So you have a negative and a negative here, so that's really going to be positive. So negative times positive is negative. All right. So you have to be careful there. And then we're going to have 2.8 times 3.9. All right. And now we're just going to pull this over to the other side. 5.7 plus 5.7. Oop, there's an x here. Okay. So we have y is equal to negative 2.8x. Now we have positive, no, we have negative 10.92. So negative, here, watch. And so it takes the last thing you have and puts it there. So I said negative this thing. Okay. So we have negative 10.92. We're going to add 5.7 here. Negative 5.22. All right. Now, let's try it the other way around. You already found the slope. That doesn't change. So we're going to say this is negative 2.8 plus b. Pick your favorite point, and we're going to choose our x and y values for them. Okay. Why don't we use the same point? We'll just say 5.7 equals negative 2.8. What's my x value? Was 3.9. All right. So here we go. If 5.7 is equal to, we're going to take 2.8 times 3.9. 2.8 times 3.9. Okay. I think we've seen that number before, haven't we? And now we're going to subtract 10.92, 10.92, and see what became of this thing. So b is equal 5.7 minus 5.7, how about? Right, 5.7 minus, right, 10.92. What do you know? 5.2. You knew that up here, I know. But that's going to be y equals mx. Well, not m, but you know what I mean. It's negative 2.8. All right. And then minus 2.0, 5.2, what was that? 5.22. Same answer. It's supposed to be. So if you're stuck, you're wondering, like, which one do you want me to use? Whichever one you feel most confident in using. Okay. So quite honestly, you should, when you're doing your homework, please practice both. You know, when the previous section has practiced this method, this section is having us practice the first method that we showed. So I urge you to practice both of them. But in a moment of panic, you're like, oh, I'm taking the test and I don't know. Pick either one. Pick the one that makes you feel comfortable and go with that. You will have a favorite tool. That's okay. That's also, of all the things you learn in intermediate algebra, this is one of the top things I think anybody ever learns. Because having a lab where you're given 2 data points and they say, connect the dots. Like, how? Like, draw a line. This is a really important thing to be able to do. All right. I think we did this one before. was close to it anyway. We have a salesperson makes a base salary of $600 a week plus 12% commission sales. Back here, you. Okay, we're going to linear model, and then we're going to figure that out. Evaluate this in the context of the problem. Okay. All right, so what do we have here? We have a salesperson, here's our salary. This is an S. Just in case anybody ever watches this that was not taught cursive, this is an S. And the reason I do it instead of this is because a lot of my students complain, they said, that's a 5. No, it's an S. So now that's an S. Okay. So person makes big salary, $600 a week plus 12% commission sales. So $600 a week plus 12%, right? That's what 12% means. You take the decimal place, you move it 2 times. That's always 4%. So if I had 9%, that is 0.09. Okay, because there's a 0 in front. We move the decimal place twice. 09. 9. All right, and then 12% commission sales. So I think they called this thing X or something. You don't have to, right? You can call it T. You can call it, well, don't call it S because we're already using that. But you can call it something else. There's a lot. There's 25 other letters. Linear function to provide the sales, person's weekly salary. I think we have that. It's 600 plus 0.12 and then X, because in this case the book said use X, so we're using X. Okay, and then when they say, well, when we put 9,000 in here, okay, so right off the bat here, before we go any further, just make a note. Okay, just to let us know what's going on with things. So S is going to be in dollars. X is also going to be in dollars. Okay, sometimes that matters, sometimes that'll help. Okay, and we're just going to crank through that arithmetic. We're going to say, okay, well, 600 plus 0.12. You don't need the leading zero for playing in a calculator. Okay, the calculator doesn't really care. But you want to write 0.12. It's not going to kill you. Yeah, it's not going to be wrong either. So it's going to be fine. Now it looks like we got 1680. Okay, 1680. There we go. Oh, what does it mean? That's the important thing. Okay, we sold, well, the store sold $9,000 of stuff on commission. This thing, what is this representing? It's representing his weekly take home, or not, maybe not take home. I don't think we've done taxes or everything, but that's just going to be his weekly pay. It's not, it's just a weekly pay. All right. So this means we have 1680. Okay. That person will make. This is actually not a bad book to go with, because a lot of times people freak. They really have a hard time with what does it mean. And really, if that ever happens to you, where you say, what does it mean? And you're like, I don't really know what to do. Start with the units. Okay, start with the units. $9,000 in merchandise is sold for the week. Okay. So be careful about that. They will ask you one where it's going to explain. But if you have to do it by hand, start with the units. Okay? Even when you're on the computer, look for the explanation that has the right units. That's usually going to be a pretty good thing to look at. Okay. I think these were all. Excuse me. This one I could see asking. The other two that we just looked at, these two. I mean, there's nothing wrong with those questions. I just don't see myself asking them. You know, the first one, there's a lot of words. It's easy to misinterpret something in there. I don't want that to be the mistake. Second one, graphical, and not a bad problem. But I tend not to ask the graphical ones because I'm terrible at drawing them. Okay. So this one looks like a good one, though. There's a lot going on. There's a lot of moving parts. They're all accessible, right? They're all, people can grasp this. It's not so bad. Okay. So we have a small business makes cookies and sell them at a farmer's market. Fixed monthly cost for the for health department, approved kitchen and rental space at the farmer's market. So they're renting space, they're renting the booth at the farmer's market, and we have $740. The cost of labor, taxes, and ingredients for the cookies amounts to 15 cents per cookie. And the cookies sell for $6 a dozen. Okay. We're at a cost function. So this is just the cost. And functions don't have to be one letter. Okay, they typically are. But you know, if it helps you to say cost equals, because that keeps it straight for you, then that's what I want you to do. Okay, so we have a fixed cost, $740. And then they have what's called a variable cost, because it's going to be 0.15 times x. X equals number of cookies, C, cost of education, or cost of, cost of, so sometimes I like to put the units next to what the variables are. In this case, it's the number of cookies. I'm just going to say n. There's no unit there, but the cost is going to be in right. Is going to be in US dollars. So we could do that. So there's my cost function. What did we say this was? 760 plus 0.15. 0.15 x. 740. All right. Oh, dozen cookies. Okay, X's and dozens of cookies. See? It's not cookies, it's dozens. So this 0.15, right? This is 0.15 per cookie. So what we need to do is we need to say 1 dozen. Oops. We need to say 12 cookies for a dozen. And then we're going to get the cost per dozen. Okay, so 0.15 times 12 is $1.8 per dozen. All right. I'll have to double check what the settings on that are. All right. There we go. A linear equation, right? Linear revenue function representing the revenue. Okay. So the cookies sell for $6 a dozen. Okay. So sell. So we'll say R of X. X is still dozens of cookies. X is going to be 6X. $6 per dozen. So Y equals 6X. All right, very good. And now we're going to figure out the profit, which is the revenue minus the cost. Okay, so profit is equal to revenue minus cost. And now we got to type that stuff in. Okay, so revenue was 6X minus the cost. Right? We can go back up and look at that cost function if you want. That's okay. Once you got it right, you can keep it. All right. But this is going to be 1.8. So we have 740 plus 1.8. Revenue minus costs. We have to simplify. I wonder if we do. 6X minus, let's see if they give us right or wrong here. 740 plus 1.8X. So let's do this. Oh, they don't like that, 740. And now we're going to have to distribute that in. So it's going to be minus 1.8X. They're going to want us to combine like terms is what they're going to want. It can be simplified. They didn't like that. Okay, so 6 minus 1.8. All right. So let's see. We could so that's going to be 42. Was my fixed cost was 720. It was 720. 740. There we go. And now they want to know, like, how many do you have to do to break even? So all we're going to do is set this equal to 0. That's when my revenue is dead even. Okay. So we're going to take what is this? X. All right. Oh, this should be a minus. Okay. There we go. Like, why did you know that? So, because when I swing it to the other side, it's going to be a positive or a negative. Dividing both sides by 4.2 here. And we're getting 720 divided by 4.2, and that is equal to divided by 4.2. 171.43 and some change. We're selling cookies and we got to break even. 172. Okay. 170 ain't going to cut it. 172 or 171 ain't going to cut it because we're still a little short. And the way that this is usually written, we have to be a little bit over for it to count as break even. Okay, so we need 172. What did I do? Oh, you did this is wrong. Okay. What did I mess up? 4.2 minus 7. Oh, 4.2 minus 740. How many times am I going to make this mistake? Okay, so we're going to divide that. You get 740 over 4.2 equals, I'm glad they told me it was only one digit, though. Give me an idea where I was going to look. 740 divided by 4.2. 76. 177. We need 177 to break even here. Okay. There we go. All right, 151 dozen companies sold in a given month. They will lose money. All right, so we're just going to plug this in. All right, but since it is, we've done about an hour. I think we're good as far as trusting you guys to put this in there. But you know, Monday we'll have exam, we'll have practice exam. We'll see how things go with that, and we'll keep reviewing. Okay, so if there's specific stuff you want to see, please let me know, and that way I can address those specific things. All right. So I will say thank you to everybody. I'll stop recording.